Hi everyone, I hope you're okay. This is video number 4, guys, which simply means I'm answering the fourth question from the past question papers, just based on Newton's laws, guys. Né? This is a question paper which was extracted in grade 12 question papers, but I still say, guys, even if you are doing grade 11, please do watch the video, because Newton's laws are only taught in grade 11, so it's only the same thing that grade 11s are doing. Okay, before we even start, guys, please don't forget to share this video, guys, to your peers. A thing or two that will be mentioned here might help them towards their upcoming test or exams, or even uplifting their knowledge as well. And please don't forget to like, comment, and most importantly, guys, please do subscribe to help us grow the channel. Okay, excuse me. We are told that two boxes P and Q resting on a rough horizontal surface are connected by a light inextensible string. The boxes have masses of 5 kg and 2 kg respectively. A constant force F acting at an angle of 30 degrees to the horizontal is applied to the 5 kg block to the 5 kg box as shown below. Né? Okay, then now you are told that the two boxes now move to the right at a constant speed of 2 meters per second. Okay, first question: state Newton's first law of motion. It simply states that a body will remain in its state of motion unless a set of unbalanced forces acts on it. Okay, and then now they want us to draw a free body diagram showing all the forces acting on body Q, on box Q. Okay, free body diagram will be like this. There's this tension which is pulling UQ towards the right, and then there's this constant frictional force that Q experienced due to the surface, and then there is normal force F normal, and then we have our gravitational force or the weight. So this will be the free diagram for object Q. Are you together? Okay, and then now we are told that box P experiences a constant frictional force of 5 newtons and box Q a constant frictional force of 3 newtons. Né? They want us to calculate the magnitude of force F. Okay, please, guys, note this term. Né? Constant speed. They even highlighted it for you. Constant speed, guys, simply means, acceleration is 0, change in kinetic is 0, F net is 0, work net is also 0. Are you together? So please do keep that in mind. Yeah? They want us to find the value of force F. Force F which is applied on body Q at an angle of 30 degrees. Okay. If we draw a free body diagram for box P, né? You can draw it in two different ways. You can draw it like this. You obviously have your gravity, weight, and normal force. There's tension and friction. And then there's that force F which is applied at an angle. Of 30 degrees. Are you together? You can draw your free body diagram like this, or instead of using this force which is applied at an angle, you can use its components. How so? You'll still have your gravitational force or the weight, you'll still have your tension, you'll still have your friction. Yes, there's still normal force. Fn. Let me indicate the components in blue. Yes, the object is being pulled at an angle, however it's moving horizontally. So that means we must have a horizontal component, Fx, and also a vertical component, Fy. Alright, together. We can calculate Fx by saying force which is applied multiplied by cos of theta, and then for the vertical component is the value of the force which is applied multiplied by sine of theta. All together, and the theta just represents the angle between the horizontal and the force. So these two ways are the two ways that you can excuse me, that you can draw your two free body diagrams. Yeah. Okay, so now let's work. Remember that we were told that the two boxes will move at a constant velocity. If you focus on box Q, just box Q alone, it's F net. Okay, we know that F net is equal to MA, but there are only two forces which are acting horizontal on box Q. We only have it's always important, guys, to choose a positive direction. Please, since our two boxes are moving towards the right, in Newton's laws, guys, like, it's always safe to choose the direction of motion as positive. It simply means that any movement to the right will be positive. So now we are focusing on box Q, right? There's this positive force plus this one which is opposing motion, frictional force. They are equals to MA. Excuse me. T minus the value of frictional force acting on body Q, that's 3 newtons. Remember that the two boxes are moving at a constant speed, which simply means acceleration is 0, and anything multiplied by 0 is 0. So 2 multiplied by the acceleration of 0 will still get a 0. So therefore the tension between the two boxes is just 3 newtons. Are we together? Okay, now remember that, guys, the aim is to calculate the value of F. Remember that, guys, we can also use body P. Are we together? Now we do know the value of the tension. That's 3 newtons. The friction was given to us as 5 newtons. In the horizontal surface, the only force we do not know is the horizontal component. Are we together? Let me write that in green. We can simply say that F net is simply equals to MA. How many forces do we have? We have 3 forces. There's only one force which is moving in a positive direction. And which force is that? Is the horizontal component. We have X plus a negative tension which is pulling body P towards the left, and a negative frictional force which is opposing the motion of body P, multiplied by MA. Remember that, guys, the value of Fx, the horizontal component, is simply F multiplied by the cos of theta. Theta is an angle between the force applied and the horizontal surface, minus the cos of 30 degrees. Then we subtract this with the value of tension. We got the tension to be 3 newtons. Our frictional force is 5. Remember that this thing is moving at a constant speed. Constant speed simply means that there is no acceleration. Acceleration is 0. If I take the mass of the object, which is 5, multiplied by 0, I'll simply get a 0. Therefore, I'll be left with F multiplied by the cos of 30 degrees is equals to 8. So therefore it's just equals to 8 all over the cos of 30 degrees. 8 divided by the cos of 30 degrees, I'll simply get 9.23 newtons. Right, together. So the magnitude of a force F is just 9.23 newtons. That's how, guys. That's how you could have solved that 6 marks question. First, go find the tension by using body Q. After finding the value of the tension, you go and substitute it here, and then you'll simply find the F. Okay. Then now we are told that let us draw the velocity time graph for the motion of P and Q before and after the string breaks, as shown as shown below. 2.4. Write down the time at which the two strings break. The time at which the two strings break. The strings will break at 3 seconds. Are you together? At 3 seconds they will break. How do I know that? Because now they won't be moving at a constant velocity of 2. The other one's velocity will increase and the other one's velocity will decrease. Are you together? So at 3 seconds, at time 3 seconds, the two strings will break. Are you together? And then, which portion X, Y, or Z of the graph represents the motion of box Q after the string breaks? Use the information in the graph to fully support your answer. Okay, remember that, guys, box Q was held by its tension. Box Q rather was held by the string which has broken. So if ever we remove the string, if ever we remove a friction, I would get not friction rather, but the tension or the string, it simply means that now there's no any other force which is trying to pull or push body Q towards the right. Are we together? Which simply means that the only horizontal force that body Q will experience is a frictional force. Are you together? So by just analyzing that, it simply means that, guys, body Q, its velocity will decrease and eventually come to 0. Are you together? So which of the two graphs will represent body Q? We can see that after 3 seconds, graph Y or this portion over here represents the motion of Q. Why? Because its velocity will decrease, because it only has a force which opposes its motion. Yes, body Q will continue moving towards the right due to inertia. Are you together? However, it will eventually come to a stop because its resultant force is opposing its motion, and that resultant force consists of a frictional force only. Are you together? So we know that friction always opposes motion. It's a non-conservative force that always opposes motion. So as much as body Q keeps on moving towards the right, it will decrease its velocity until it comes to a stop. Are you together? However, for box P, its velocity will now start increasing. It will now start increasing. Why? Because dragging this other box was slowing box P down. Are you together? So now there's no tension. Now there is no tension. Excuse me. There is no tension now. Are you together? And we know that this force is definitely bigger than this one. Are you together? Hence, now body P will start accelerating because initially when the body P was joined with the body Q, there was no acceleration. They were moving at constant velocity. But immediately, whenever we remove a tension, we will only have the same force which is applied and the frictional force. And this force is greater than that one. Are we together? So now forces are no longer balanced. Hence, we will see an acceleration for body P. Hence this portion here, the portion of X is the one that will represent body P, and this one is the one that will represent body Q. I hope this guys make sense. Please guys stay tuned and wait for more videos, and please don't forget to share the video to your peers. Don't forget to like, comment and subscribe to help us grow the channel. Thank you very much.